Welcome and hello. This is a video tutorial in HEC HMS, and in this lesson we're going to be discussing forecast alternatives, specifically running the computation and viewing the results. All right, what I have on the screen here is my HMS model. It's a very simple model with one subbasin and one sink element. What you see over here in the Watershed Explorer are the components. So there's, of course, the basin model. There's a meteorologic model that I have set up, and then that's using a specified hydrograph that is referencing a gauge 1 down here, a precipitation gauge. If I go over to DSS view, I have that precipitation gauge data loaded up right here. It is the first 10 days of January, I believe. Here's the plot. So you can see we have a big storm on January 2nd, and then again on January 9th and 10th. So back to HMS here. Over in the Compute tab, I have a simulation run as well as a few forecast alternatives created already. I'm going to go ahead and just quickly create a new one. So I'm going to just grab the name there, and then we'll create it from scratch. We'll go up to Compute, Forecast Alternative Manager, New, and then I'll give this the name for January 12th. Okay, next. We'll use the one and only basin model and the MET model, and we'll use a 1 hour time interval and finish. All right, so this is the forecast alternative we just created. There's more information on creating the forecast alternative with more details in the previous lesson, number 65. I'll go ahead and leave a link to that in the description. All right, with that new forecast alternative created, I can come down here and set the start and end date time of the simulation as well as the forecast date right here. Okay, so I'm going to start on the beginning of the year, January 1st. And then the forecast date will be the 11th, and then the end of the simulation, I'm sorry, it will be the 12th. The end of the simulation will be the 13th, and then we will just put the time of day at 0 hours. All right, so the time interval is 1 hour as before. For my subbasin, I have created a zone. So if I go up to parameters, zone configuration manager, it's the simplest zone configuration and zone you can imagine. It only contains the subbasin 1 right here. So you can see the zone is just called zone 1, and then the element is my subbasin 1. Okay. So with that set, I can go ahead and set my zone configuration right down here. And I don't have any reaches, so I don't have a reach configuration. I can't make any edits there or parameter adjustments. All right, now to the actual content of the exercise. We're going to learn how to run the simulation and then view the results. There's a number of ways to run the simulation. The first thing you want to do is select the forecast alternative that you want to run. I use the term run simulation, and I really shouldn't. There is run simulations, there's optimization trials, and now we're looking at forecast alternatives. So to compute the forecast alternative, go ahead and select that forecast from the dropdown right here. If you don't see this compute toolbar, you can go up to View, Toolbars, and then Compute. That's how you toggle it on. Also, we're going to need this Spatial Results toolbar later. So go up to View, Toolbars, Compute, and then, so the first way is just to click this Compute button right here, and the computation has ran. That forecast alternative has got results saved now. Another way to do it is with our forecast alternative selected here, we can go up to Compute and then compute this forecast. And then in brackets, you see the actual name of the forecast alternative. So that's another way to run it. A third way to run that compute is to come over here to the Compute tab in the Watershed Explorer. Right click on the forecast alternative you want to run and then click Compute. And there are two more bonus ways that the user's manual doesn't mention, but I'll show them to you anyway. You go up to the Compute toolbar, and the first is to click on this Forecast Parameters table, and then click on the Clark. Oh, you can click on any of the different transform methods or options there, and then click Compute right here. That's another way to run the computation. You don't have to change the actual parameter values. If I click on subbasin, I'm using the Clark unit hydrograph transform method, 10-hour time of concentration. And the last way to compute a forecast alternative is to come up to Compute, is to use the slider bar adjustment. There's an automatic computation that occurs when you change the values. So let me go ahead and add that real quick. Click Zone 1, time of concentration, select is fine. We'll close that, and then let's go ahead and click on Forecast Parameter Sliders There's more details about how the sliders work and updating the parameter values in the previous lesson. That is lesson 66. I'll leave a link to that as well. All right, so with this checkbox checked, it will automatically compute if I change the time of concentration. So if I just scale it up to 1.55, that ran as well. All right, I'm going to run it one more time with 10-hour time of concentration. That looks good. Next, the user's manual describes running a forecast alternative to a computation point. So I don't have any computation points in my model. It's such a simple model. There's no reason for one really. But if I wanted to have if I had a large model and I only wanted to run a forecast down to a specific computation point, i.e. a location represented by a hydrologic element in the hydrologic network, then I could just create a computation point by saying right click, select computation point. Then it gets this little red dot here, as well as a little red dot here in the Watershed Explorer. And then from there, I could just right click, compute to point. That way, nothing downstream of that computation point is calculated, and everything upstream of that computation point is calculated. It's a way to simplify the computation for that forecast alternative. To remove the computation point, I could just go right click, unselect computation point. There's also a computation point manager, I believe here. There it is. So I can add and remove computation points that way. All right, the last way to compute forecast alternatives is to do so multiple forecast alternatives at a time. So as I mentioned, I have a number of forecast alternatives that I've already created with different names and then dates. So if I wanted to run all of these at the same time, I'd go up to the compute menu, multiple compute. Now, by default, the compute type is simulation run, but I also have these forecast alternatives. Go ahead and click the checkbox beside every forecast alternative you want to run. I guess I could have clicked select all and then click compute, and then that ran for all 6 forecast alternatives. Next, it's time to view results from that forecast alternatives that we ran. Let's just focus on this last one for now. Viewing results for forecast alternatives is just like simulation runs. For instance, one way to do it is just to click on an element like the subbasin and then go up to the results menu, which is right here. And then we can select the graph, summary table, or time series table. So if we click on the graph, we see the results right here. We can do the same thing with the summary table right here. And then the time series table, which is basically the same values that make up that graph. We have that data right here. So these 3 results are sort of a reoccurring theme of graph, summary table, and time series. So for instance, if I have that same subbasin selected, I can click on graph, summary table, or time series table. So that's what this looks like. Okay, so I'll go ahead and close those. Also, whatever element is selected, that is the data that we're going to view when we click on the graph. So for instance, we were just looking at this subbasin plot for the forecast alternative. This is the results from our computation. But if I click on the sync element right here and then click on the plot, I'm just seeing that hydrograph, not the hyetograph like we saw when we were looking at the subbasin results. A couple other ways to view the results is to come over here to the results tab, expand that forecast alternatives folder, and then we can see the results by just clicking on the name of that forecast alternative and then the element. And then again, we have graph, summary table, and time series table. So if I click on graph, it pops up just like before. And then down here are different values that have been saved as DSS records. So cumulative outflow, precipitation, cumulative precipitation. This data is saved in the DSS file that was exported. So let me go back to the compute tab, click on that forecast alternative. And then you see here, this second field here just below description is output DSS file. This gives me the path that the results were saved to. So within my project here, I have the name of the DSS file. So this is the 5th and final way to view results. Let's go there. So I'm going to go ahead and open up the DSS file. I need to go up a level, and then this is my main project directory. And as you see, we have a DSS file associated with each of the forecast alternatives. So that last one that I just created for January 12th, I'll select that DSS file, click open, And now I have all the records, all the paths for data from that forecast alternative compute. Part B shows the element type, whether it's the sink or the subbasin, and then part C is the type of data itself. So if I wanted to look at the runoff or the flow from the sink, then I could just go ahead and look at that graph once again. And DSS View is a good way to be able to view data from multiple forecast alternatives at the same time. So I could load up a separate file, move the paths around, and then open up that data and view it using the graph or the table. Another way to view results from multiple forecast alternatives at the same time is to go into the Results tab. And right now I only have that January 12th forecast expanded, but I could also open up the same results for the different forecast alternatives. And if I wanted to compare the outflow between the two subbasins for these two forecast alternatives, I would just select outflow, hold down control, scroll down to the next outflow, and then click it again. Now this happens to probably be the exact same data just because my model is oversimplified, but that was how you would do it. If you wanted to compare the plot or graph of a hydrologic time series for multiple forecast alternatives. Something else that the user's manual mentioned is to change the graph properties or the plot properties. If you open up a graph, for instance, actually, let me go ahead and open up the sync graph. So this is just the hydrograph. If I wanted to change the color of the line or the thickness or something else about it, there's a ton of different options in Edit Plot Properties. I'm not going to go into too many details here because there's too much to talk about, but you basically got your different time series data here. You also have different tabs across the top for like the series data itself, viewport, title, axis, legend, markers, and layout. So you can change the color. I'll just very simply change the blue to a green, and then I'll make the line thickness a little bit darker. Click apply, and there we go. That's not really green, but okay. Oh, I see what's happening. Okay, so it was basically a blue line on top of a green line, and it looked dark green. All right, so here's our outflow. Here's the data, and yeah, if you click on the legend, that will also highlight that particular series. The last part of this exercise deals with viewing spatial results. So let me show you how that works. If you go back to the Compute tab in the Watershed Explorer and then click on your forecast alternative, at the very bottom of the components editor, there is a couple fields here for spatial results and spatial interval. So go ahead and change that no to a yes, and then select the spatial interval if you want to save the spatial results for your computation, for your forecast alternative when you run the compute. For my particular model here, it's set to no and it's grayed out because my project is not geo-referenced. For spatial results to even be possible, whether it's a forecast alternative or a simulation run, your project needs to be geo-referenced with a coordinate system. Your subbasins need to be discretized, like a structured discretization, for instance. And then the transform method also needs to be mod Clark or 2D diffusion wave. So once all those things are true, you'll be able to select your spatial results, run the computation, and then view the spatial results by going out to View, Toolbars, Spatial Results, and then select the variable you want here, run through the simulation, and then change some different settings, symbology, and things like that. I'll leave a link to the lesson that I made for viewing spatial results as well. It's for simulation runs, but all the things I say in that lesson apply to the forecast alternatives as well. Well, that was it for this lesson. We talked about running a forecast alternative and viewing the results in HEC HMS.